Readings in Chapter 3, which covers Chapter 3.1 and 3.2, which is on vectors. The first problem in the homework is problem 5, and it asks, is it possible to add a vector quantity to a scalar quantity? Explain. And the answer to this is no, just because by definition, a vector is a quantity with direction and magnitude, whereas a scalar is just a number, like the magnitude of a vector is a scalar, but the vector itself is not a scalar. The vector is a vector. So just by definition, you can't add a scalar and a vector. The next question is question 6, which says vector A is 3.0 units in length and points along the positive x-axis. So we'll draw a little graph up here for reference. So that's positive x and that's positive y. So we're going to draw vector A, which is 3.0 units this way, and then vector B is 4.00 units in length and points in the negative y-axis. So vector B is going to be 4 units. And part A says, use graphical methods to find the magnitude and direction of the following vectors. Part A asks, A plus B. And we just go tail to tip. So A, which is 3, plus B, which is 4. And so to find our direction and magnitude, we need to find this, which is going to be our magnitude of our vector. So this is A plus B, and then we need this angle. So to find the magnitude of A plus B, we just need to use our Pythagorean theorem. So the magnitude of A plus B is going to equal the square root of 3 squared plus 4 squared, which is rad 9 plus 16, which is rad 25, which equals 5. So A plus B is 5 units, and our angle, to figure out the angle, we could use any of our trigonometric identities, but usually the easiest one to use is tangent. So tangent of theta is going to equal opposite over adjacent, so 4/3. And then we take the inverse tangent, we get our angle equals the inverse tangent of 4/3, which is, go over to our calculator, 53.1 degrees. So vector A plus B is 5 units, and it is 53.1 degrees below the x-axis. So this is our positive x-axis, so it's 53.1 degrees below the positive x-axis. Now part B, well, it's A minus B. So again, we go tail to tip. So here's A, and this is 3 units. And then minus B. So for plus B, B went down. Now to add a negative vector, you just do it in the opposite direction. So instead of going 4 units down, we're going to go 4 units up. And again, draw a vector connecting them. This is going to be A minus B. And to calculate the magnitude of A minus B, again, we're going to use the Pythagorean theorem. We're going to get square root of 3 squared, which is 9, plus 4 squared, which is 16, which is rad 25, which is, of course, 5. So again, we get 5 units. So our magnitude is 5 units. Kind of cut that off. 5. And to get the angle, we just want to use the inverse tangent again. So to get our angle, we can just skip. An easy way to remember how to skip a step is the angle is going to be the inverse tangent of the opposite side of the angle over the adjacent side to the angle. So this is going to be our angle. We want the inverse tangent of our opposite, which is 4, over our adjacent, which is 3. And if we plug that into our calculator, which we already did, it's 53 degrees. And if you notice, this problem is looking a lot like this one, because both these vectors, A and B, have the same magnitude. But the difference is, this is 53.1 degrees above the positive x-axis, whereas this is 53.1 degrees below the positive x-axis. So 53.1 degrees above the positive x-axis. Now part C is going to ask, it wants vector A plus twice vector B. So we remember A is 3 units, the positive x direction, and B is 4 units in the negative direction, but it's 2B, so we just draw that twice. Imagine those are the same length. They're a little different. I apologize. This is 4.0, 4.00. So this total length is 8.00. And again, draw something connecting them. So to figure out this distance, we need to use Pythagorean theorem again. So square root of 3 squared plus 8 squared is, my pen's dying, square root of 9 plus 64, which is rad 73, which is 8.54 units. And to figure out our angle, we need to take the inverse tangent. And let's use this as our angle. The inverse tangent of opposite over adjacent, so 8 over 3. Also, you want to make sure your calculator is set in degrees. If you have a calculator like this, the TI-84, you go into mode, and you go down into where it says radians and degrees. Make sure degrees is highlighted, press enter, and then hit clear. For other calculators, you'll have to figure it out on by yourself or look it up. Usually there's usually a couple buttons up here that might say radians or degrees or something like that. So you take the inverse tangent of 8/3, and we get 69.4 degrees. And again, we need a direction for this angle. So this is going to be 69.4 degrees below the positive x-axis. Below the positive x-axis. And if you don't write this on quizzes, you will get points off. Part D is B minus A. So we'll start with B. And vector A is normally 3 units this direction, but since it's negative, we want to go 3 units this direction. It's going to get in the way, isn't it? So to figure out this, again, it's Pythagorean theorem. Square root of 3 squared plus 4 squared, we've done about 3 times. It's 5. And then to find our angle, we're going to take the inverse tangent. This is our angle. Actually, the inverse tangent of 3 over 4, which is going to be 36.9 degrees. And usually we want to have our angle with respect to the x-axis, so you could do it with respect to the negative x-axis. So since this is 36.9 degrees, it would be 53.1 degrees, so that could be 53.1 degrees below the negative x-axis. Or you could also do this angle plus 90 degrees. So 36.9 plus 90 degrees, which you're going to get 126.9. So you could go 127 degrees clockwise from the positive x-axis. clockwise from positive x-axis. And just be clear that these two things mean the same thing. You don't need both of them, just have one of them. The next question is question 11, and it says, give an example of a moving object that has a velocity vector and an acceleration vector in the same direction, and an example of one that has a velocity and acceleration vector in opposite directions. So a good example for this is a car. So if you have, and I changed my pen color by the way, the other one's dying. I hope this orange isn't too offensive to the eyes. So if you have a car that's going, let's call that east, and it's accelerating east, so this is velocity, and this is acceleration, and they're in the same direction. So this is like, you started your car going east, and you're pushing on the gas, and you're going faster, you're accelerating. So that is an example of an object with velocity and acceleration in the same direction. Call this A, even though it doesn't have parts. And now we want velocity and acceleration in the opposite direction. So if we have velocity going east and acceleration going west, that means you're going along in your car and you hit the brakes. So your velocity changed in the opposite direction, so it decreased. So your acceleration is in the opposite direction of your velocity. And hopefully this makes sense. This is just translating what we've learned earlier about positives and negatives into vectors. So east and west, or I mean, you could do this north and south and north, or whatever you want to do. Just pick directions. Next question is question 12, and I'm going to give you a heads up. Question 12 is a little weird and a little stupid. It says, a student accurately uses the method for combining vectors. The two vectors she combines have magnitudes of 55 and 25 units. The answer that she gets is either 85, 20, or 55. Pick the correct answer and explain why it is the only one of the three that can be correct. Now, if you take a vector with the magnitude of 55, and a vector with a magnitude of 25, if you put them tail to tip, the biggest total magnitude you can get is 80 meters. And if you flip it the other way and go 55 and 25, the smallest magnitude you can get is 30 meters. Is it in meters? Oh no, it's units, not meters. So the book wants you to realize that the longest distance you can get from adding two vectors is by putting them tail to tip in the same direction. Now, say if you had 55 this direction and 25 this direction, your answer is going to be longer than 55 but shorter than 80. I mean, I could calculate it if I figured out an angle or whatever, but the longest you'll ever get is when you put them in the same direction, tail to tip. And the shortest you ever get is when you put them in opposite direction, tail to tip. But and the correct answer for this problem is actually 55, because 85 and 20, I mean 85 is bigger than 80, so you can never get that, and 20 is less than 30, so you can never get that. But how you'd get 55 with a vector with a length of 55 and 25, you really can't. So it's a very stupid problem. But the answer is 55. The next question is question 15, and it asks, can a vector have a component greater than its magnitude? And the answer is no, and here's why. So a vector, let's say we have a vector, we'll call it A. It has an x component, so this is A sub x, and a y component, it's supposed to be a dotted line, A sub y. And the problem's asking, can either of these ever be greater than A? Um, and the answer is no, like I said, because they form a right triangle, and by the definition of a right triangle, either of your legs can never be longer than the hypotenuse. Otherwise, you get some shape that doesn't even make sense and doesn't work when you try to draw it on paper. I mean, the closest you could get is having one of the components equal to the length of the vector, and that's only if they're in the same direction. So if you have a vector like this, then b of x equals 0 because it's not going in the x direction. Sorry, that's supposed to be straight. So it's not going in the x direction, it's only going in the y direction. And since it's going in the same direction as its y component, b of y equals b. But that's not really important. Really what's important is you have to know that the legs, or the x and y components of a vector, form the legs of a right triangle, where the hypotenuse of the right triangle is the vector itself. So by definition, the components cannot be longer than the hypotenuse. The next question is question 18, and it asks, how would you add two vectors that are not perpendicular or parallel? And the answer is, like, let's say we had vector A and vector B. And to do this, you'd split them up into their x and y components and add those together. So you'd have a sub x, a sub y, and then b sub x and b sub y. And this vector AB would have the components of, sorry, I'm drawing these a little out of the way so you can see them. Actually, that's a bad example. Vector AB, or A plus B, sorry, would have the components A sub x plus B sub x. So the x component of vector A plus B would be the sum of the x component of A and the x component of B. And then the y component of vector A plus B would be the sum of vector A sub y and vector B sub y. The next question is question 22, and it says, a girl delivering newspaper covers her route by traveling 3 blocks west, 4 blocks north, and 6 blocks east. So let's draw a picture real quick. 3 blocks west, so remember, draw a quick little compass, north, east, south, west. So 3 blocks west, 3. 4 blocks north. That's pretty big, 4 blocks. Sorry. And 6 blocks east. And part A asks, what is her resultant displacement? So that means this. And to figure out this total displacement, we need to form a right triangle. So I'll separate this triangle out. And this is what we're looking for. And we know that this side is equal to this side because these are parallel. So this is 4. And this side is just going to be 6 minus 3, which is 3. So this side here is going to be the square root of 4 squared plus 3 squared, which is rad 25, which is 5. And also you need a direction for that. So to find our angle, we'll just pick this as our angle. That's a really bad looking theta. We'll go inverse tangent of opposite over adjacent, so 3/4 equals theta. So to do that, we're going to go inverse tangent of 3/4, and you get 37 degrees. And you need a direction, and since we're in cardinal directions, this is going to be 37 degrees east of north. And if it doesn't make sense to you, you have to remember that this is in the north direction, because here's our compass, and this is all lined up with that, because she went west, north, east, which lines up with the compass, obviously. So that means for this little triangle that we pulled out here, this direction is going to be north, this direction is going to be east. So this angle is 37 degrees east of north. I don't know if I said north of east earlier. If I did, I messed up. It should be east of north. 37 degrees to the east of north. Because if you're going north and you move 37 degrees, you'll be 37 degrees east of north. So that's part A. And then part B asks, so we have our angle and our magnitude. Then part B asks, what is the total distance she travels? So for total distance traveled, it wants this plus this plus this. So 3 plus 6 plus 4, which is 13. So 13 blocks. Also, I suppose you need a unit up here. Next question is question 23, and it says a submarine dives 110.0 meters at an angle of 10.0 degrees below the horizontal. What are the horizontal and vertical components of the submarine's displacement? So we have a submarine diving for 110 meters, or 110.0 meters, at an angle of 10.0 degrees below the horizontal. So this is horizontal, and this is horizontal, and this is 10 degrees below the horizontal. And it wants the horizontal and vertical components. So this right here, this distance is our horizontal component, and this distance is our vertical component. So to figure these out, and let's just call this vector v, and we'll call this v sub y and v sub x. So v sub x is going to be equal to, well, actually, to figure these out, we're going to be using trigonometric identities. And so we want an identity that has 2 of our knowns and 1 of our unknowns in it. So we're going to pick, let's start out with cosine, which is going to be adjacent over hypotenuse. So our cosine of our angle is going to be equal to our adjacent, which is v of x, over our hypotenuse, which is 110.0 meters. And we multiply that over, and we get 110.0 cosine of 10.0 equals, let's find out, 110 cosine 10 is 108.3 meters, and that's our horizontal component, which we called v of x, but you can call it anything you want, as long as you know that it's your horizontal component. And then for our vertical component, we need a trigonometric identity that has our 2 knowns and our 1 unknown, so we're going to use sine, which is opposite over hypotenuse, so sine of 10 degrees equals v of y, our opposite over our hypotenuse, which is 110, multiplied over again, 110 sine 10, whoops, and that's going to give you 19.1 degrees, or sorry, 19.1 meters, 19.1 meters. So this is your horizontal component, and this is your vertical component. Question 24 says, a quarterback takes the ball from the line of scrimmage, runs backward for 10 yards, and runs sideways parallel to the line of scrimmage for 15 yards. At this point, he throws a 50-yard forward pass straight down the field. What is the magnitude of the football's resultant displacement? Okay, that's a lot to take in. So we'll start him here, center of the page at the line of scrimmage. He runs backwards for 10 yards, 10.0 yards. Runs sideways parallel to the line of scrimmage for 15 yards. And then throws a forward 50-yard pass. So it wants to know the total displacement of the ball, so we just take where it started and where it ended, and we draw a line. And to figure out what the length of that line is, the magnitude of our displacement vector, we need a right triangle. So I'm going to pull this right triangle out so it's easier to visualize. So this is what we're looking for, the displacement. This is 15 yards, sorry. And then this length is going to be the 50 yards minus the 10 yards here, so 40 yards. And to figure out the total, the displacement, we're going to use Pythagorean theorem, so square root of 40 squared plus 15 squared, and you're going to get 42.7 yards. And then we need an angle, which, actually no, it doesn't want an angle. So it's just 42.7 yards, and there's your answer. The next question is question 25, and it says a golfer takes 2 putts to sink his ball in the hole once he is on the green. Sorry, question 25. Once he is on the green, the first putt displaces the ball 6.00 meters east, and the second putt displaces it 5.40 meters south. What displacement would put the ball in the hole in one putt? So to do this, we're going to draw a picture real quick. We have 6.00 meters this way, and this is east, and then 5.40 meters this way into our hole. So it wants to know what would it take, well, what direction and magnitude would he have had to putt the ball in order to get it from here to here in one putt. In other words, it just wants the resultant vector. So to find the direction and magnitude of that, first we're going to do magnitude because it's easiest. You can do square root of 6 squared plus 5.4 squared. I can't do that in my head. So square root of 6 squared plus 5.4 squared, and that's going to give you 8.07 meters, which is the magnitude of this length, or the magnitude of this vector. And then to find the angle, we're going to use the inverse tangent. So the inverse tangent of the opposite over the adjacent, so 5.40 over 6.00. This will give us our angle, 5.4 over 6. And we're going to get 41.98 degrees. I'll call it 42 degrees. 42 degrees, and we need a direction on that, so this is going to be it's going to be south of east. So we're going east, you turn 42 degrees, and you're 42 degrees south of east. So 42 degrees south of east. The next question, question 26, reads, a person walks 25 degrees north of east for 3.1 kilometers. How far would another person walk due north and then due east to arrive at the same location? So this is basically the opposite of the last problem. Instead of giving you 2 component vectors and asking for a resultant vector, it's giving you a resultant vector and asking you to find 2 component vectors. And I'll show you what I mean. So 25 degrees north of east, so here's east, and 25 degrees north, 25 degrees for 3.1 kilometers. And we want to know, and we'll call this our vector A. You don't need a name for it, I just want a name for it. I think it makes things easier. So it wants to know the east and the north component, so we're going to call this A sub E for east and A sub N for north. So again, we're going to need trigonometric identities that have 2 of our knowns and 1 of our unknown. So to find A, we're going to use the cosine, because cosine is adjacent over hypotenuse, and so cosine of 25 degrees equals our east component of vector A over our hypotenuse, which is 3.1 kilometers. Multiply this over, we get 3.1 cosine 25 is going to equal our east component of vector A. So 3.1 cosine 25 equals 3.81 kilometers. Sorry, 2.81 kilometers. And we need a direction, which is going to be east. Now to figure out our northern component of our vector A, we're going to use the sine, because sine is opposite over hypotenuse. So sine of 25 degrees equals the opposite side, which is our north component of our vector A, over our hypotenuse, which is vector A, which is just, or sorry, the magnitude of vector A, which is just 3.1 kilometers. Multiply it over, and you get 3.1 sine 25 degrees equals north component of vector A equals 3.1 sine 25 equals 1.31 kilometers. 1.31 kilometers, sorry about that. And again, we need a direction, so it's going to be north. The next question is question 27, and it asks a roller coaster traveling a roller coaster travels 41.1 meters at an angle of 40.0 degrees above the horizontal. How far does it move horizontally and vertically? This is basically the same as the last problem. It gives you a magnitude and an angle of a vector, and it wants you to find the horizontal and vertical components, aka the x and y components. You can think of it many ways. So 41.1 meters, and it wants, so 41.1, yes, at an angle of 40.0 degrees, and sorry, that's 40.0 degrees, and it wants our horizontal and our vertical. So we're gonna, and again, let's call this vector B. So we'll call this B sub horizontal, or B sub H for horizontal, and B sub V for vertical. So to find, and again, just like the last problem, we're going to need to use trigonometric identities to identify these values. So first we're going to take the cosine of our angle. It's going to equal our adjacent side, which is our horizontal component, over our hypotenuse. Multiply it over, 41.1 cosine 40 equals 31.5 meters. And then take the sine of the angle to find our vertical component. Because again, sine is opposite over hypotenuse, which is our vertical component over our magnitude. Multiplied over. Then plug it in. And you get 26.4 meters. And there you have it. Yeah, that's the horizontal and the vertical component of this vector. Next question is question 28, and it reads, a shopper pushing a cart through the store moves 40 meters south down one aisle, makes, so 40 meters south down one aisle, makes a 90-degree turn and moves 15 meters, and then makes another 90-degree turn and moves 20 meters. And it says, note that you are not given the direction moved after any of the 90-degree turns, so there could be more than one answer. And what they mean by this is, you could have gone this way then 90 degrees this way, and then 90 degrees this way, or this way, then this way, or this way, then this way. There's a lot of, and I went this way. So there's actually 4 different answers you could get out of this problem, but we're not going to do any of those. We're just going to do one. So here's our resultant vector. Yeah, and it says find the shopper's total displacement. So we're going to simplify this into one triangle first. We're going to get, so first we want this side, then we want this side. So this whole side is 40 plus 20, which is 60 meters. And then this side, I drew that too long, that's 15 meters. And here's our resultant vector. Ignore that little bit. And we want this angle as well. So to find the resultant, we're going to take, we're just going to use the Pythagorean theorem again. So square root of 60 squared plus 15 squared equals 61.8 meters. And to find our angle, we're going to go inverse tangent of opposite over adjacent. So 15 over 60. 15 over 60. And we get 14.0 degrees. And you need to specify that angle. And since it said initially that this direction was south in the beginning of the problem, it says she moves 40 meters south down one aisle, that's this direction. So we can only assume that this is east, that's west, that's north, so on and so forth. So that means this angle is east of south. So 14 degrees, this is south, that's east, so east of south. And that's just one of the answers to the problem. Like we set up here, there's actually 4. The next question is the last question, and admittedly it looks really hard, but it isn't. It's just a lot of obnoxious work. So it shows a little diagram. It says a person walks a path shown in figure 3-27. The total trip consists of 4 straight line paths. At the end of the path, what is the person's resultant displacement measured from the starting point? So it looks like this: 100 meters, 300 meters, 150 meters. That's really bad. That's not the angle I wanted. And it's 30 degrees below this. So this is 300. This is 150. And then 200 meters at 60 degrees above the vertical. And it wants this. So the way we're going to figure this out is we are going to have to split both of these up into x and y components and combine them with these two to figure out this distance. And I'll show you what I mean in just a second. So first thing we want to do is we're going to split off this triangle. So it gives us 30 here, 150 here, and we want, we'll call this vector A. We want a sub x and a sub y. So to find a sub x, we're going to do 150 cosine 30 equals, and you can do this on the calculator. I'm just writing it down. And then for a sub y, we're going to do, because I mean I've done this several times in previous problems, 150 sine of 30 degrees, and that's going to give you 75. So this is 75, and this is 130. And then we're going to do the same thing over here, and take this triangle, pull it out. So this is 200 meters, this is 60 degrees, and we will call this vector B. So we want our B sub x and our B sub y. So to find B sub x, we're going to do since it's adjacent to the angle cosine again. So 200 cosine 60 is going to equal 100, so b sub x is 100 meters. And then for b sub y, we're going to do 200 sine 60, because sine is opposite over hypotenuse. And we're looking for our opposite, and that's going to be 173 meters. So now we want to combine all of this into one big quadrilateral thingy instead of angles. So we'll take a new piece of paper, and we've got 100 meters here, 200 meters, or sorry, 300 meters here. And then for the next part, we have this component, our a sub y, which we said was 75 meters. So we have, let's draw these as vectors. We have another 75 meters. And then our a sub x is 130 meters, so we went 130 meters. And then over here, we went this direction, which is our b sub x, which is another 100 meters. And then we went up our b sub y, which is 173 meters. And we're looking for this. So now that we've got it into a big quadrilateral, we can make a little triangle of just what we need. So we're going to pull this triangle out. And we're going to figure out this distance first, which is going to be this 300 meters minus this, oh sorry, this plus this minus this. So we have 375, so this is going to be 375 minus 173, which should give you 202. And then this side, which is going to be this plus this, which is 230, minus this, just to get this part right here. So we need 230 minus 100, which is 130. So we'll redraw our triangle again. We have 202 and 130. And we're going to take the we're going to use the Pythagorean theorem real quick to figure out this distance. So we're going to use the square root of 202 squared plus 130 squared, and we're going to get 240.2. We'll just call it 240. And then we need this. This is a horribly misproportioned triangle, by the way. This is 202 and this is 130. This side should be a lot longer, but deal with it. So now we need this angle theta. And to find that, we're going to do the inverse tangent of the opposite over the adjacent. Which is going to give us 32.7 degrees. Or sorry, 32.8 degrees. Now we need a direction for that. So that's going to be west of south. This direction south. Move up 32.8 degrees in the west direction. So it's 32.8 degrees west of south. Thank you for watching this episode of PHS Physics SOS. I hope you found it helpful. If you have any further questions, particularly on that last problem, or any problem in fact, it's just that last problem is kind of tough, feel free to leave a comment in the YouTube, leave a comment in the YouTube comments below, or ask me on Facebook or in the Facebook group, and I can help you individually over Facebook or over Skype. Thank you for watching.